Settle in and let your breathing slow down, as if the whole room is listening with you. Outside, there is pre-dawn rain, soft and steady, and you are on a forest trail where everything smells like wet cedar and cold stone. Somewhere above the clouds, Mount Rainier is there, but you cannot see it yet, which is comforting in a strange way. You might think this is just a quiet mountain, holding still for the day, but it is a sleeping volcano, built layer by layer and wrapped in heavy ice that never truly stops moving. Tonight, with the Sleepless Geographer, you will follow the slow stories, ice to river, river to valley, and gravity doing what it always does, patiently. The first thing you learn standing here under dripping branches is that Rainier does not need fire to be dangerous. Lava is the dramatic option. Rainier prefers something more practical, something that behaves like wet concrete with opinions. Mud flows. Thick, gray slurries of water, ash, clay, and broken rock, sliding downhill with the single-minded focus of gravity. And the strange part is that the mountain can send those mud flows without erupting at all. You walk a little farther, boots soft on needles and soaked soil, and you feel how normal everything is down here. A road not far away, a town waking up, a school bus route, probably, people making coffee, checking weather, complaining about rain as if it is optional in Western Washington. Above all of it is an extraordinary skyline, an enormous volcano that spends most mornings hiding behind a curtain of cloud, like it is refusing to be perceived. Rainier has that habit. It lets you forget it exists until the air clears and it suddenly fills half the horizon, like a thought you were trying not to have. You think you are looking at a single mountain, a solitary peak. But that is the postcard version. The quieter truth is that you are looking at a whole structure of stacked eruptions, old avalanches, buried glaciers, and valleys shaped for speed. Rainier is less a mountain and more a system, a high, cold reservoir of rock and ice, waiting above the lowlands. And the lowlands are not empty. If you spread a map in your mind, you can feel the population around you like warm lights in the dark. Tacoma, Puyallup, Orting, Auburn, parts of Seattle, farther north, still within reach of the river valleys that drain this volcano. People live here the way people always live under big landscapes, by letting the background become background. The forest trail bends, and the rain finds new surfaces to tap. Ferns, swordgrass. Your jacket. The steady percussion is gentle, almost sleepy. But rain is not just weather here. It is a tool, a delivery system. It shows up quietly and starts loosening the mountain, one drop at a time. This is where you begin, not at the summit, not in hero air, but in the damp, low elevation where danger looks like moss. Because on Rainier, the path to catastrophe is often made of ordinary things: water, gravity, loose rock, a slope. And as the clouds lift a little, you start noticing the mountain is not just a peak, it is an entire water system hanging in the sky. You get a break in the canopy, and there it is for a moment. Not the whole mountain, just a suggestion, a pale shoulder above the darker ridgelines. It looks unreal, like a painted backdrop. The glaciers are up there, out of sight from this wet forest, but you can feel their presence anyway, the way you can feel the weight of a storm before it arrives. Rainier is heavily glaciated, which is a polite way of saying it is wearing a thick, bright armor of ice, not decorative ice. Working ice, ice that creaks and fractures and slides. Ice that never fully stops moving even when the world below is asleep. A glacier is not a frozen lake. That is the mistake people make. They see white, they assume stillness, but a glacier is more like a slow river, a heavy blanket that has decided to flow. Gravity pulls it downhill, and the ice responds the way any thick material responds, by deforming, by cracking, by inching along. When you stand near glacier ice, you sometimes hear it, a low groan, a small snap, a sound like wood shifting in an old house. That is not the mountain talking. That is the ice doing its job. And the job is simple. It takes snow from the high, cold places, compresses it into ice, and delivers it downward, where it becomes water again. Not in one dramatic moment most of the time, just in steady, patient melt. But on Rainier, you also have warm rain. This is the Pacific Northwest, after all. The air can arrive from the ocean thick with moisture, and it does not always come in gently. Sometimes it comes in warm, heavy sheets that fall on snow and ice like someone turning on a shower. The kind of rain that feels wrong in winter, the kind that makes the mountains sweat. Warm rain is efficient. It carries heat. It eats into snowpack. It pours into cracks and tunnels in the ice, and it finds the hidden plumbing beneath the glacier. You do not see most of that plumbing from a trail. It is under the surface, under the white. Meltwater channels, little caves, dark veins where water runs fast under a slow body of ice. When that water is released, it does what water always does. It runs downhill. It gathers. It picks up grit. It becomes a stream, then a louder stream, then a river that looks innocent from a bridge because you are only seeing its surface manners. Now, add something else. Volcanic rock. Rainier is built from layers of eruptions, ash, lava flows, broken fragments, older slopes collapsed and rebuilt. A lot of it is not solid granite like an ancient mountain range. It is volcanic material that can be surprisingly crumbly once it is fractured and altered by water and heat. Some of the rock has been chemically changed over time, turned into soft, clay-rich zones inside the volcano, like rotten wood hidden inside a tree. So you have steep slopes, ice above, water moving, and rock that sometimes behaves like wet chalk. Congratulations, you have all the ingredients for a lahar. Lahar is the word geologists use. It sounds tidy, almost elegant. In human terms, it is a fast-moving river of mud and boulders, dense enough to carry trees like toothpicks. It can start at the volcano and keep going far downstream, following river valleys like rails. It does not have to be hot. It does not have to glow. It does not have to look like the movies. It can happen because a chunk of ice collapses, or because warm rain melts snow quickly, or because an earthquake shakes loose a weakened slope, or because the volcano wakes up and rapidly melts its own glaciers. Many options. None of them need your permission, and the unnerving part is how far it can travel. Rainier's mud flows have reached the lowlands before, spreading out where valleys widen, laying down thick, flat plains of silt and gravel. Those plains are beautiful in their own way. They are fertile. They are easy to build on. People look at them and think, this is convenient. The land does not care what you think is convenient. You keep walking, and you can imagine the water above you, even if you cannot see it yet. Ice feeding melt, melt feeding streams, streams joining other streams, like whispered conversations turning into a crowd, all of it heading toward the same low places, because gravity does not improvise. It repeats itself. The everyday version of this is gentle. A small creek under a log, clear water carrying a dusting of sand. The creek is doing the same work as a lahar, just at a polite speed. It is sanding the landscape, grain by grain, rearranging the mountain slowly enough that you can pretend nothing is happening. But the process is the same. Water plus loose earth equals movement. You step over roots that braid the trail like knuckles, and you notice how the ground feels springy in places. That is soil built from centuries of rain and decay. Rainier is not only making rivers, it is making dirt. It is shedding itself a little at a time, and the forest is catching it like a blanket. This is the soothing part, if you let it be soothing. Even danger here is mostly just gravity. Being honest, the mountain lifts material into the sky, and the world spends the next 1,000 years pulling it back down. Follow that meltwater downhill, and you will find it gathering itself into valleys, beautiful, green, and shaped like old scars. The valley you imagine first is narrow, V-shaped, a classic river cut. But near Rainier, many valleys were also shaped by glaciers in the past. Those older ice rivers carved deeper, wider troughs. And when the ice retreated, the rivers inherited the shape. That is a quiet theme on this mountain: inheritance. Ice leaves behind a channel. Water takes it over. Mud flows borrow it when they need to travel. The land keeps passing the same pathways down through different eras, like a family habit. You can picture the valleys as long corridors radiating out from the volcano. The Carbon River Valley, the White River Valley, the Nisqually, the Puyallup. Names that sound gentle when you say them slowly, as if they are describing calm water and green banks. And often they are calm. Most days, the rivers just murmur along. They braid and split over gravel bars, cold and milky with glacial silt. They carry tiny rock flour that makes the water look like melted glass, pale and opaque. That flour is the sound of ice grinding stone. It is the mountain being filed down. But those same valleys are built for speed when something heavier arrives. If you spill water on a flat table, it spreads out. If you pour it into a gutter, it runs. Valleys are gutters for landscapes. They focus flow. They guide it. They offer the easiest route, and everything moving downhill appreciates an easy route. Mud flows, when they happen, do not fan out randomly at first. They lock into valleys and accelerate, taking curves like a freight train. They can climb up the outside bends, leaving strange high water marks of mud and debris. They can bulldoze forests, then leave behind a raw corridor of gray sediment that looks like a fresh wound. And then, downstream, when the valley finally widens, the mud flow slows and spreads, and it lays down its cargo. Sand, gravel, boulders, tree trunks, the broken parts of the mountain, all sorted into a new plain. Those plains are why the Puyallup Valley looks the way it does. Flat, broad, fertile. A place that invites farms, roads, neighborhoods, warehouses. You look at flat land and your brain says, safe, stable, useful. But flat land at the mouth of a volcano valley is often flat because something made it that way, something that needed room to spread out. Rainier's slopes are made of volcanic layers, and those layers can be weak. Imagine a layer cake left out in the rain. Some parts hold, some parts slump. Over time, water seeps into cracks, freezes, expands, loosens blocks. Chemical reactions turn hard minerals into softer clays. Heat from inside the volcano, even when it is not erupting, can circulate warm fluids that alter rock. So the mountain contains zones that are strong and zones that are rotten. You cannot tell from a distance. From a distance, everything looks like a single clean cone. Up close, it is more like a construction site that has been running for 500,000 years, with no manager and no final inspection. Humans, naturally, prefer the smooth, flat places. We build there because it is easy to pour concrete on a flat surface. We plant there because soil collects there. We drive there because it is less annoying than hills. This is not a moral failing. It is an animal instinct. Choose the easier ground, but the land remembers old paths even when you forget. The rivers remember where the low points are. Mud flows remember where the channels point. Floods remember the broad plains they have visited before. And when the mountain decides to send something down, it does not negotiate with zoning laws. Still, the morning down here remains quiet. The rain stays soft. The forest keeps drinking. The danger exists mostly as a story written into the shape of the valley. You can live a whole life in these lowlands and never see a lahar. That is part of what makes it unsettling. Long, calm stretches are excellent at convincing you that the past will not repeat. But Rainier has repeated itself before. Geologists read those repetitions the way you read layers in a cake or rings in a tree. They find old mud flow deposits buried beneath modern soil, sometimes beneath towns. They date the wood trapped inside, and they reconstruct the timing. They learn which valleys were used, how far the flows traveled, how often the mountain has rearranged the lowlands. And then, politely, they tell everyone nearby that the mountain is not finished. Those flat places were made by movement. And speaking of movement, the whole Pacific Northwest is quietly sliding and squeezing beneath you. You do not feel it under your boots, not right now. The forest trail feels stable. The trees do not sway. The rain falls in its usual vertical way. But beneath all of this is a boundary between giant slabs of the Earth's crust, and it is not a peaceful boundary. Out west, under the Pacific Ocean, there is an oceanic plate moving slowly toward North America. It is called the Juan de Fuca Plate, and it is not large compared to the Pacific Plate, but it is stubborn. It keeps pushing east, like a slow conveyor belt you cannot turn off. Where it meets the North American plate, it dives beneath it. This is subduction. It sounds like a bureaucratic term. In human language, it is one thick rug sliding under another, except the rugs are rock, and the friction can shake cities. The edge where that ocean plate goes down is the Cascadia subduction zone. It runs offshore from Northern California, past Oregon, past Washington, up toward British Columbia. Most days, it is quiet. That is the trick. It locks up and stores strain for a long time, like someone slowly bending a giant wooden board. Then, once in a while, it snaps. The result is a large earthquake. the kind that changes coastlines and knocks clocks off walls and turns roads into ripples. The kind that arrives without warning because the planet does not send polite emails. That same subduction also helps feed volcanoes like Rainier. As the oceanic plate sinks, it carries water and minerals and sediments down into hotter depths. That water changes the melting point of the rocks above, encouraging magma to form. Magma is molten rock, but it is not a big open lake under the mountain. It is more like pockets and mush zones and pathways, slowly accumulating over time. Volcanoes are not simple pipes. They are plumbing systems built by pressure with blockages and reroutes and occasional catastrophic leaks. Rainier is part of the Cascade Range, a line of volcanoes that exists because of this subduction. Mount St. Helens, Mount Hood, Crater Lake, which is what is left after Mount Mazama collapsed in an ancient eruption, a chain of peaks that look serene in photographs and are, in a way, because their violence happens on timescales that do not match your calendar. Earthquakes and volcanoes are different moods of the same engine. An earthquake is the crust-releasing stored strain. A sudden slip along a fault. A volcano is the crust, allowing magma and gas to rise, a slow pressure problem that sometimes becomes dramatic. They are related, but not identical. Still, in the Cascades, you cannot talk about one without feeling the other breathing in the background. And Rainier sits close to a lot of people. It is not the tallest mountain on Earth, not by a long shot, but it is tall enough, icy enough, and steep enough to create very efficient downhill routes. It is also heavily monitored because humans like to know when the ground might misbehave. There are seismometers around it, listening for small quakes. There are river gauges watching water levels. There are hazard maps showing potential lahar zones drawn in calm colors that try not to alarm anyone too much. There are sirens in some communities designed to wail if a mudflow is detected, an ugly sound meant to cut through everyday life. But most of the time, nothing happens. Most of the time, the subduction zone stays locked. The volcano stays quiet. The glaciers creep. The rivers carry silt. Rain falls on cedar and fir. The danger remains a background fact, like the existence of the ocean or the inevitability of winter. That long calm is part of the story. It is what allows forests to grow thick. It is what allows towns to expand. It is what allows you, right now, to stand on a trail in the dark and hear only rain and distant water. With all that deep pressure below, it is comforting to return to the surface, to the forests that grow in the mountain's shadow, softening everything. Down here, the world is green in layers. Moss drapes over fallen logs like old velvet. Ferns uncurl with slow confidence. Needles collect in damp quilts at the base of trunks. The air smells like wet bark and soil that has been busy. This is not a tropical rainforest, but it has that same sense of constant moisture, of water always being present in some form. Drip from leaves, fog clinging to branches, thin rivulets running beside the trail, finding the lowest place without any fuss. Rain does gentle violence here. It breaks rock down into soil one patient season at a time. It seeps into cracks and reacts with minerals, turning hard edges into softer grains. It encourages roots to pry apart fractures as trees grow, because a tree does not care about your idea of solid stone. A tree sees a crack and thinks, excellent, space. When a log falls, it becomes a sponge. It soaks up water and becomes home to insects and fungi. It slowly collapses into dark, rich matter, and that matter becomes the next generation of forest. Decay is not an ending here. It is a kind of quiet industry. You step over one fallen trunk and feel how it has become soft, almost crumbly, held together by moss and habit. A nurse log, they call it, because it supports new seedlings on its back. The dead tree becomes a bed for the living, and this constant recycling builds the ground beneath your feet. Soil is not just dirt, it is a layered archive of weather, plants, time, and broken rock. On the flanks of Rainier, the soil can be young in some places, buried and replaced by old volcanic ash, by landslide debris, by flood deposits. It can also be thick and dark, where the forest has been undisturbed. The roots knit it together. They hold slopes in place. They slow erosion. They catch falling material and keep it from rushing downhill all at once. In a way, the forest is doing damage control for the mountain. It is trying to keep everything from sliding at the first opportunity. But roots only hold as long as the conditions let them. Fire can remove that grip quickly. Floods can undercut it. Landslides can peel whole sections of hillside away, roots and all, like someone tugging at a rug. And time, of course, is always working, slowly loosening the stitches. Even so, the dominant feeling in this forest is not urgency. It is patience. The water falls, the moss grows, the wood rots, the soil thickens. Collapse happens, but often it happens gently, disguised as natural change. The forest makes the volcano feel quieter than it is. It muffles sound. It softens slopes. It hides raw rock behind ferns. It makes you believe you are in a stable, living world. And you are, for now. But if you keep walking upward, the trees thin out, the air cools, and the landscape starts speaking in stone instead of leaves. The trail climbs, and the forest begins to change its tone. The trunks space out, the understory becomes simpler, the air feels sharper, less saturated with the smell of rot and sweetness. You start seeing more exposed ground, more gravel, more places where plants have not had the chance to cover everything. The higher you go, the more the mountain shows you its raw materials. Pumice, light, and porous, like stone that tried to become foam. Dark rocks, heavier, volcanic, sometimes rough as if they cooled too fast to smooth out. Pebbles that crunch under careful steps. The sound is different from the forest floor. Less hush, more brittle texture. Up here, plants struggle. The growing season is shorter. The soil is thinner. Wind dries things out. Snow lasts longer. And when plants cannot hold the ground, erosion becomes more visible. The mountain looks like it is shedding. Wind is constant, not always strong, but always present, brushing the surface, lifting dust, nudging loose grains downhill. Wind is a sculptor that never clocks out. It does not take weekends. It just keeps sanding edges, lowering ridges by fractions you do not notice until you zoom out across centuries. And water, of course, is still here. It runs in small channels beside the trail, cold enough to sting if you dip your fingers in. It disappears into gravel, then reappears lower down because the mountain is full of porous layers and hidden pathways. Volcanic deposits can be like that. They can hold water, then release it, then shift it sideways through unseen spaces. When you look up toward the white higher slopes, you can imagine the glaciers again. They are not just scenic, they are storage. They store water in winter. They release it in summer. They grind rock into fine silt. They load rivers with sediment. They shape valleys. And if conditions align badly, they contribute to the kind of sudden flow that becomes a problem far below. This is the part people forget. The summit is not isolated from the lowlands. Everything on a mountain is connected by downhill. A rock falls up here, and eventually, its dust can end up on a beach. Meltwater forms in a hidden tunnel, and eventually, it can water a farm field. A slope collapses, and the debris can become new land for a neighborhood that will one day name its streets after trees. Mountains are not permanent monuments. They are active negotiations between uplift and erosion. Rainier exists because the Earth keeps feeding magma upward, building layers over long time. But Rainier also exists in a losing battle with weather. Every year, rain, ice, wind, and rivers take a little away. The mountain is always rising and always being worn down at the same time, like a person trying to walk up an escalator that is moving down. You do not need to climb. You do not need thin air and heroic suffering. You can just imagine it. Imagine decades of wind brushing a ridge. Imagine centuries of snow pressing into ice. Imagine 1,000 summers of meltwater carrying grit downstream. The changes are small, but the sum is enormous. And if you linger long enough, you start to notice the mountain has two kinds of time. There is the fast time, the time your body understands, a gust that knocks grit into your eyes, a bead of meltwater that finally lets go, the sudden clatter of a small rock slide somewhere upslope, a quick sound, then silence again. And there is the slow time, the time the mountain prefers, the long, patient lowering of ridgelines, the steady creep of ice, the quiet settling of loose volcanic layers into the valleys below. Up here, above the densest trees, you can see how much of the surface is simply unfinished. The ground is a mix of rough rock and young soil stitched together in patches. Some places are armored with stones that refuse to break down quickly. Some places are bare and fragile, like they have only recently been exposed. You think you are walking on solid ground, stable and agreed upon. Wrong. You are walking on a slope made of old eruptions, rearranged by storms, and held together by roots that are doing unpaid labor. If you look closely, you find the small evidence of motion everywhere. A fan of pebbles spread below a cliff where gravity has been collecting its tips. A shallow channel cut into ash where last week's rain decided to become a stream for 10 minutes. A patch of snow with dirt streaks, proof that the wind has been sanding the surface even in winter. This is why high volcanoes can look so clean from far away. From far away, all the messy parts blur into one smooth cone. From far away, you can pretend the mountain is made of one strong substance, like a statue. Up close, it is made of layers and weak seams and places where water has turned hard rock into soft clay. It is made of angles that want to slide. It is made of materials that behave beautifully right up until they do not. Congratulations! You have reached the part of the mountain where it stops pretending, and you do not have to go all the way to the summit to feel the thinness. Even at these middle elevations, the air carries less warmth. The breeze has a sharper edge. The sun, if it appears, feels bright but not generous. It lights the landscape without comforting it. You can hear water here in a different way too. Down in the forest, streams whisper through moss and roots, muffled by soft ground. Here, water makes a more honest noise. It clicks over gravel. It taps at stones. It runs under snow in hidden little tunnels, making a hollow sound like someone stirring a drink in the dark. Everything is pointed downhill. That is the central truth of mountains. Every path is a future route. Every gully is a promise. Every valley is a suggestion the land has made about what will happen when something decides to move quickly. You stand still for a moment and imagine the mountain in a heavy rainstorm. Not the gentle drizzle of a quiet morning, the thick, warm kind that arrives in a wet wind from the Pacific Ocean. Rain that falls like a sustained decision. It lands on snowfields and glaciers, and instead of freezing, it melts. It pours into cracks and molens, those vertical shafts in ice that swallow water like drains. It runs along the boundary between ice and rock, and that boundary can be slick like a bar of soap pressed against a countertop. When enough water gets involved, the glacier can speed up for a while. Not like a car speeding up, like a heavy dresser being nudged across a floor. It still moves slowly, but the friction changes, and when friction changes on a steep slope, the whole mood changes. Then imagine an earthquake, not even a giant one. Just the kind of shaking that makes branches shiver and pebbles dance. On a volcano with altered rock, a tremor can be enough to wake up a landslide that has been thinking about it for years. And when a landslide starts high on an ice-covered mountain, it often becomes something else. It mixes with snow and ice. It breaks into smaller pieces. It picks up water. It turns into that dense slurry again, the one that does not need lava. Lahar, the tidy word for a messy event. The strange comfort is that none of this is personal. The mountain is not hunting you. It is not angry. It does not even know you exist. It is simply built in a way that produces certain outcomes when the ingredients line up. Water plus loose volcanic material plus gravity. And you get movement. This is why hazard maps around Rainier follow valleys instead of circles. People sometimes imagine volcanic danger like a blast radius, as if the volcano is a bomb, but the most likely paths are not evenly spread. They are channeled. The mountain has carved grooves down its sides, and those grooves are the routes the future will prefer. So you let your imagination drift downhill now, not in a rushed way, but in a steady descent, following the way water thinks. You start as meltwater on the upper slopes, cold and new, carrying a dusting of rock flour. You find a trickle, then join another trickle. You become a small stream running beside pumice and dark stones. Then you drop into a valley, and the valley takes over. The valley is like a long handrail guiding you toward the lowlands. It is steep at first, then less steep, then suddenly wide, as if the land is making room for whatever arrives. And that is how you begin to understand the shape of risk here. Not as a dramatic circle around the peak, but as a set of corridors reaching outward into places that feel far away from the mountain. It is easy to forget how far water can travel when it has a head start. Rainier gives water elevation. That is its gift. That is its threat. Because elevation is stored energy, disguised as scenery. A drop of water high on a glacier has potential. It has somewhere to go, and as it falls, it spends that potential as speed and force. The same is true of rocks, of snow, of mud. So you follow the valley farther, and you notice how it changes personality. Up close to the mountain, it is narrow, tight, forested in places, with steep walls that feel like they are leaning in. In some sections, you can stand in the bottom and see the walls rise like a hallway built by geology. But as you move away, the valley opens. The river begins to braid, splitting into multiple channels across a wide bed of gravel. The water looks milky because glaciers have been grinding stone into powder and handing it down. The river is carrying the mountain in a form that will not be obvious until later, a fine sediment that will become silt, then soil, then something someone will call farmland. A braided river is honest about its indecision. It cannot commit to one channel because it is overloaded with sediment. It drops gravel bars, then switches lanes. It spreads out, then gathers again. It is always reorganizing itself. That constant reorganization is beautiful in a gray, practical way. And it is also a reminder that rivers are not stable features. They are moving machines, cutting and filling, shifting sideways, pretending to be permanent only because you do not watch for long enough. When you cross a river like this on a bridge, you see water and you assume it is just passing through. But the river is working. It is chewing at banks. It is undercutting roots. It is picking up stones and rolling them downstream, one slow tumble at a time. In flood season, the work becomes louder. Water rises, brown and urgent, and the river becomes a demolition crew with no schedule. It rips at the edges of its own channel. It eats into the valley floor. It carries logs like battering rams. Then, when it calms down, it leaves behind new bars, new deposits, new rearranged paths. This is why the valleys below Rainier look so inviting. They are wide and flat because rivers and mudflows have been doing landscaping for thousands of years. They have been spreading material out in thin, even layers. Flat land is a gift and a receipt. It is proof that something once flowed here heavily enough to make it level. So you drift farther down into the places where people live. You come to towns that sound like they belong to rivers, because they do. You come to roads that follow the valley, because the valley makes driving easier. You come to neighborhoods built on old deposits, because those deposits are stable enough most of the time, and most of the time is what humans build for. Here is the quiet problem. Most of the time, the river behaves. Most of the time, the mountain stays quiet. Most of the time, the hazard is only a paragraph in a brochure or a diagram in a classroom. And then, once in a long while, the land remembers itself. People often ask, How fast would a lahar move? It depends on the valley. It depends on water content. It depends on how much debris is involved. But the unsettling answer is fast enough to matter, fast enough that you do not have time to negotiate with disbelief. In some valleys near Rainier, the estimated travel time from high slopes to the lowland towns can be measured in tens of minutes. Not hours, not a leisurely afternoon, minutes. This is why there are lahar sirens in some communities. They are not there to create drama. They are there because the best defense against a fast-moving slurry is not fighting it. The best defense is leaving the channel. Mudflows prefer low ground. They want the valley bottom. So survival is often just going uphill, away from the river corridor, without wasting time arguing with yourself about whether the siren is real. That is the practical truth. But practicality is not what your brain likes at night. Your brain prefers big, cinematic dangers, lava fountains, explosions. The bright stuff, a lahar, is the dull danger, the gray danger, the wet concrete danger. It is, in a way, the most Pacific Northwest hazard imaginable. Something fueled by rain and quiet erosion, arriving with no theatrical glow. And because it is dull, it is easy to underestimate. So you keep following the valley in your mind, and you start to notice the land has a memory. Geologists look for that memory in cut banks and gravel pits and construction sites, in the places where humans dig and accidentally expose the past. In the side of a riverbank, you might see layers. A dark soil layer where a forest once stood for centuries. A sudden, thick layer of gray sand and gravel, dumped quickly, with no time for plants to grow through it. Another soil layer above that, another sudden deposit. Each sudden layer is a story of movement. Sometimes you find buried trees, snapped and entombed, preserved in sediment like messages. And with careful dating, you can learn when those trees died. That is how we know Rainier has sent major lahars in the past, even without a big eruption attached. One of the most famous is called the Osceola Mudflow. It happened about 5,600 years ago, give or take the imprecision of deep time. A large part of Rainier's northeast flank collapsed, not a small landslide, a significant piece of the volcano. The resulting lahar swept down and spread across the lowlands, building much of the land that now holds parts of modern towns and cities. The Osceola deposit is thick in places. It changed the shape of the region, and you did not need an apocalyptic explosion to do it. You just needed the mountain to lose its grip. That is the kind of history Rainier carries quietly under its snow. Then there is the electron mudflow, much more recent in a human sense, around 500 years ago. It moved down the Puyallup River Valley, leaving deposits that are still there, still legible. That is not ancient myth. That is within the span of recorded history in many parts of the world. If you live in these valleys now, you are living on the work of those flows. Your flat ground is a gift from a disaster you did not witness. Congratulations, you are living on a geology event. This is not meant to frighten you. It is meant to orient you. Because once you see the landscape this way, it becomes less mysterious. It becomes a system. A mountain supplies material. Ice and rain supply water. Valleys supply channels. Gravity supplies insistence. The only question is timing. And timing is the one thing geology refuses to promise. So you let the valley fade back into a quieter version of itself, because most nights are quiet nights. The river runs cold and steady. The gravel bars sit in their usual places. The forests on the banks stand with their roots in damp soil, and the towns go on being towns. A grocery store parking lot under a cloudy sky, a high school football field lit in the rain, a row of houses with wet roofs and warm windows. Ordinary life beneath an extraordinary volcano. It is almost tender the way humans do this. We take the most indifferent landscapes and we build a schedule anyway. We make commutes and birthdays and mortgage payments under the shadow of things that have been erupting and collapsing for hundreds of thousands of years, and the land lets us most of the time. Now, speaking of movement that is too slow to feel and too big to ignore, you return to the deeper layer again, the restless edge of the continent, because it is always there, under everything. The Pacific Northwest is not just a rainy corner of a peaceful plate. It is the edge of a subduction zone, and that means the whole region is perched on a long-term mechanical problem. The Juan de Fuca plate is sliding beneath North America at a rate that is roughly the speed your fingernails grow. It is not dramatic in a single day, but over centuries, that motion adds up, and it does not slide smoothly. It locks. The plates press together, and friction holds them like two rough boards clamped tight. Meanwhile, the motion continues. So strain builds. Imagine pushing on a heavy piece of furniture that does not move at first. Your muscles tense, pressure accumulates, then suddenly it shifts, and all that stored effort releases at once. That is the earthquake problem. Cascadia has produced very large earthquakes in the past. The last full margin earthquake, the one that involved a long stretch of the subduction zone slipping, happened in the year 1700. That date is surprisingly exact, and it is not because someone in coastal Washington was taking notes with a seismograph. We know because of trees and mud and a very polite kind of detective work. Along parts of the coast, there are ghost forests, stands of dead trees, their trunks still rooted in tidal mud. They died when the ground suddenly dropped during an earthquake, and salt water flooded the soil. The trees did not rot completely because the conditions preserved them. If you count the rings, you can see they died in the same season. Then, across the Pacific Ocean in Japan, there are records of an orphan tsunami, a tsunami that arrived with no felt earthquake locally. That means it came from far away. The timing matches, so the year 1700 sits there in the region's memory like a pinned note. And if you live in the Pacific Northwest, it is one of the quiet facts behind modern building codes and tsunami evacuation signs. Most of the time, again, nothing happens. But the physics does not go away because you are busy. Now, how does this connect back to Rainier? Subduction zones feed volcanoes over a long time, but they also shake them. An earthquake can destabilize slopes on an already steep, already fractured, already ice-covered volcano. It can shake loose landslides, it can crack glaciers, it can trigger avalanches. So you have a region where the deep engine can, in theory, set multiple surface processes in motion. Not like a neat chain reaction every time. The Earth is not that organized, but like a complicated household where one slammed door can rattle 3 shelves. And volcanoes themselves are part of this tectonic story. As the oceanic plate sinks, it heats and releases water. That water rises into the overlying mantle and helps rocks melt. The melt is buoyant, so it rises. But the journey upward is not simple. Magma stalls. It cools. It crystallizes. It mixes with other batches. It picks up gases. It finds cracks and weaknesses. Sometimes it erupts. Sometimes it just sits there, slowly changing the chemistry of the rock around it. Rainier's magma is typically andesite and dacite, which are thicker, stickier magmas than basalt. In human terms, they flow less easily, and they can trap gases more stubbornly. Trapped gas is where explosive potential comes from. When gas cannot escape gently, pressure builds. When pressure builds, eruptions can be more violent. Rainier has a history of eruptions that produced ash, lava flows, and pyroclastic flows, those fast, hot clouds of ash and gas that move like collapsing storms. They are not the most likely hazard for the far lowlands, but they are part of the mountain's toolbox. And yet, even when you talk about magma and gas, the most persistent threat remains water and gravity, because Rainier is iced. An eruption that melts ice quickly can generate lahars, even if the eruption itself is not large. Heat plus ice equals sudden water, and the mountain is already made of loose, broken material. So the volcano does not need to throw lava at the lowlands. It can simply turn its own glaciers into fuel for mud. That is why Rainier is often described as one of the more dangerous volcanoes in the world, not because it is guaranteed to erupt tomorrow, but because of the combination: big ice, steep slopes, weak rock, large downstream populations, valleys that aim directly into developed areas. It is a perfect recipe for a problem that starts in silence. And the monitoring reflects that. There are instruments listening for earthquakes that could signal magma movement. There are sensors watching the rivers for sudden rises and changes in sediment, because a lahar makes the river behave differently. There are cameras and satellites tracking changes in the glaciers in the summit area. If the mountain begins to change its patterns, people want to know. Not because knowledge stops the earth, but because knowledge buys you minutes. And sometimes minutes are the only currency that matters. Now let the deep tectonic pressure fade into the background again, because it is too big to hold in your hands for long. You return to something smaller, something close. The forest and rain, the soft work of rot that keeps happening no matter what the plates are doing below. Down on the lower slopes, everything is damp again. The air is heavier with plant smells. The light is dimmer under thick canopies. Water beads on moss and hangs from needles, as if the trees are storing it for later. In this climate, rocks do not get to stay sharp for long. Chemical weathering is slow, but it is relentless here. Water carries acids made by decaying plants, and those acids react with minerals in rock. Feldspar turns into clay. Iron minerals rust. The hard edges soften. You can think of it as the mountain being slowly digested by its own ecosystem. The forest is not just living on the volcano. It is dismantling it, and the dismantling becomes soil. Soil that can be deep and springy, full of roots and fungal threads, and tiny organisms doing their quiet work. Soil that holds water like a sponge, releasing it slowly into streams. That slow release is part of why the region is so green, even in drier weeks. The ground has memory too, holding moisture and letting it seep out over time. Fallen logs are everywhere because trees grow fast and die eventually, as all confident things do. A log on the forest floor becomes its own landscape. First it is bark and hard wood, then fungi move in. Mushrooms appear like small lanterns after rain. Beetles chew tunnels. Moss carpets it. Seedlings root into it, using it as a raised bed above the saturated soil. This is the nurse log idea again, and it is one of the gentler patterns on the mountain. Death becomes structure, and all of this organic matter mixes with volcanic ash, and with glacial silt, and with sand from river floods, creating a soil that is both rich and young, constantly renewed, constantly rearranged. But the forest has limits. Roots hold slopes together, yes, but only as long as the slope is not undercut. A river can chew at the base of a bank until the upper part collapses, roots and all, like a curtain falling. Heavy rain can saturate soil until it loses friction, and then the hillside can slide in one slow, inevitable sheet. Even in the forest, you can find small landslides, scars where the soil is peeled away, exposing raw mineral ground beneath. The vegetation comes back eventually, but the scar remains for a while like a reminder. This is what landslides often are here, not dramatic cliffs collapsing, but wet soil deciding it would rather be downhill. In a warming world, this balance shifts. Snow lines move, rain falls where snow used to fall. Winter storms carry more water. Glaciers thin over time, changing how they store and release meltwater. None of that guarantees a specific disaster on a specific day. Geology does not schedule like that, but it changes the baseline conditions, the background tension in the system. Now, you begin to climb again in your imagination back toward the place where the forest thins and the land speaks in stone. Because above the trees, you can see the mountain's processes more clearly. There is less cover, less softness, fewer living things trying to hide the raw surface. The slope becomes a mosaic of rock, ash, snow patches, and hardy plants that stay low to avoid the wind. Here, you can see erosion as an active verb. A small gully has been carved by meltwater, its sides crumbling into the channel. A fan of debris spreads below it, showing where the material has been delivered. A boulder sits alone, as if dropped there, because it was, carried by ice once, then left behind when the ice retreated. These are glacial erratics, the misplaced stones of a former world. They look permanent, but they are just visitors. Wind here is not a storm. Not necessarily. It is a steady presence that never gets tired. It lifts fine ash and moves it a short distance, again and again, until it accumulates in little hollows. It scours snow into ripples and cornices. It whispers across pumice like sandpaper. And you begin to understand a simple truth about mountains. They are not built to last. They are built to be worn down. Even as tectonics and magma push them upward, weather pulls them down. The result is a shape that is always changing, but so slowly that your eyes cannot catch it. If you want proof, you can look at the rivers again. Rivers are the mountain's export system. Everything that breaks off up high eventually joins a river, and the river carries it away. This is how the mountain becomes a valley. This is how the valley becomes a plain. This is how the plain becomes a coast. And since wind and water are such reliable sculptors, it makes sense to visit a place where they have had nothing but time to work. So you let yourself drift away from Rainier for a while, following the logic instead of the map. You follow a river that has left the volcano behind, and now it cuts into older rock, carving a canyon that looks like a wound that never quite closes. You are standing at the edge of it now. Not a tourist overlook with bright railings and a gift shop, but a quiet rim where the ground drops away and the sound changes. Down below, the river murmurs, small from this height, but persistent. It is the same voice you heard in the forest, just amplified by stone. The canyon walls are layered, and those layers look like pages in a book you cannot finish in one night. Some layers are dark and dense, old lava flows cooled into hard rock. Some layers are lighter, softer, made of ash and sediment that settled gently before being lifted and cut again. You might think canyons are made by one big event, an earthquake splitting the earth open, a giant crack. Wrong. A canyon is usually made by patience. A river does not have to be large to be effective. It just has to be consistent. Day after day, it carries grit, sand and pebbles that scrape the bed. The river becomes a moving file, grinding downward. In floods, it does the loud work. Water rises, brown and heavy, carrying boulders that thump and roll, punching at the channel bed. Whole trees slam into bends. Banks collapse in chunks. The river claims more space. Then the flood recedes, and the river goes back to murmuring, as if nothing happened. But the canyon remembers. Every flood leaves marks. Every season of normal flow polishes the channel a little deeper, and over thousands of years, the river cuts down far enough that the walls become steep. Gravity helps by pulling loose blocks into the river, where they are broken and carried away. This is the partnership. Water cuts, gravity collapses, and time pays the bill. If you lean forward and listen, the sound from below is not just water. It is also small rocks clicking, rolling, grinding. That is the river's teeth. And notice something else. The river does not only cut downward, it also cuts sideways. On bends, the fastest water presses against the outer bank, eroding it. On the inside of bends, slower water drops sediment, building a point bar. So the river migrates. It wiggles back and forth across its valley, slowly shifting its position, stealing land from one side and gifting it to the other. This is how valleys widen, not by a single dramatic widening, but by a lazy sideways shuffle repeated over ages. In some places, you can see old river terraces, flat steps along the canyon walls, remnants of previous floodplains left stranded when the river cut deeper. Each terrace is a past version of the river, preserved like an old shoreline. So when you look at a canyon, you are looking at multiple timelines stacked on top of each other. The rock layers record deposition and eruption and sedimentation. The terraces record incision and climate shifts. The current river records the present, which will eventually become another terrace if the cutting continues. This is why rivers are such good storytellers. They cannot stop moving. Even when they freeze in winter, the ice eventually breaks and water returns to its work. And the work is always the same: carry the mountain away. This brings you back to Rainier again, because the principle is identical. A lahar is just a river temporarily turned into wet cement. A normal river is a lahar slowed down and given manners. Gravity is still the boss. It pulls everything toward the sea. So you stay with the canyon for a while longer because it is comforting in its honesty. A canyon does not hide what time has done. It exposes it. And if you are awake at night thinking about your own small timelines, it helps to watch a landscape that measures time in layers and walls and slow cutting. People have tried to live in canyons, of course. They build roads along the bottoms because the canyon floor is flat compared to the walls. They build rail lines because following a river is easier than climbing. And then, inevitably, rockfalls happen. Freeze and thaw loosen blocks. Rain saturates cracks. Gravity pulls. A boulder drops onto the road, and humans act surprised, as if the canyon promised stability. Congratulations, you built infrastructure inside a falling landscape. Even without rockfalls, rivers flood. A canyon can funnel water like a pipe. When storms hit upstream, water rises quickly downstream. The same narrowing that makes a canyon beautiful also makes it dangerous during high flow. But again, most of the time, the river is quiet. Most of the time, it just talks to itself down there, carrying sand and polishing stones. And eventually, every river becomes a traveler, carrying its tiny pieces of mountain toward the coast. So you follow it to where land meets the ocean. The air changes first. It becomes saltier. Even before you see the water, the wind feels broader, less filtered by trees. The clouds often look lower near the coast, stretched into long gray sheets that seem to rest on the horizon. Then you hear it, the slow percussion of waves. Not a tropical crash, not a bright sound. A steady folding, like the ocean breathing in and out with no interest in your schedule. You stand on a shoreline that is calm in color. Gray water under gray sky. Dark, wet sand. Driftwood scattered like bones. Dunes behind you topped with tough grasses that lean into the wind. This coast is not trying to impress you. It is simply doing its job, rearranging the edge of a continent. A beach looks like a resting place for sand, but sand does not rest. Sand is a traveler, always in transit, moved by waves and currents, lifted and dropped, stolen from one stretch of coast and delivered to another. Beaches are made of stolen mountains. That is not a metaphor. It is a supply chain. Rivers bring sediment down from high places, carrying rock broken by glaciers and rain. They dump it at their mouths, building deltas and sandbars. Then, waves take over. Waves approach the shore at an angle most of the time, and that creates longshore drift, the sideways movement of sand along the coast. Grain by grain, the beach migrates. A storm can redraw the shoreline overnight. It can strip sand away, exposing cobbles and hard layers beneath. It can cut a new channel for a river mouth. It can pile dunes higher in one place and flatten them in another. Then calmer seasons return, and the beach slowly smooths itself again. as if embarrassed by the mess. The coast is a place where the planet never stops editing, and offshore, the forces that feed Rainier are still present. The same subduction zone that makes volcanoes also makes tsunamis. When a large earthquake lifts or drops the seafloor, it displaces water. That displacement becomes a wave train that moves across the ocean, fast in deep water, then slowing and rising near shore. A tsunami in the open ocean may be a low swell, barely noticeable. Near shore, it can become a wall of moving water, or more often, a fast-rising flood that surges inland, dragging debris and sand and anything not bolted down. On some coasts, the first sign is not a wave. It is the ocean pulling back, suddenly exposing seafloor that is usually underwater. That retreat is the ocean gathering itself for the return. If you ever see that, the correct response is not curiosity. The correct response is leaving, uphill, away from the water. The coast has its own sirens and signs in places, its own evacuation routes, its own quiet acceptance that beauty here comes with instructions. And yet, like everywhere else, people live along the edge. They build houses with windows facing the water. They walk dogs on wet sand. They collect smooth stones without thinking about how long it took to make them smooth. They treat the ocean like a background noise machine, which, to be fair, it is until it is not. Still, most days, this shoreline is restful. Waves fold in, foam spreads like lace, then dissolves. Gulls drift overhead with the bored confidence of animals that do not pay rent. Driftwood logs lie above the high tide line, bleached and twisted. Some of them come from far upriver, carried out by floods, then tossed back onto land by waves. A log can travel more than people do, without ever buying a ticket. Dunes sit behind the beach, shaped by wind. Wind picks up dry sand and moves it inland, where grasses trap it. Over time, dunes grow and shift. They can swallow fences. They can creep toward roads. They can also protect the land behind them, absorbing storm energy like soft walls. Even dunes are temporary architecture, and if you look inland from the coast, you can almost trace the whole story backward. The flat lowlands built from mud flows, the river valleys carved and filled and carved again, the slopes of the volcano shedding material, the summit hidden in cloud, holding ice like stored time. From the coast, the continent looks stable. A thick green edge, dark forests, distant mountains like a painted line. But you know better now. The continent is moving. The coastline is shifting. The mountains are being dismantled. The ocean plate is diving beneath everything, slowly loading the system with future earthquakes and future magma. From the coast, you can also feel how wide the world is. Waves arrive from storms thousands of miles away, born in distant low-pressure systems. The water carries that energy across the Pacific Ocean, delivering it to this beach in slow, rhythmic pulses. The ocean connects places that never meet. And speaking of places that look peaceful while storing energy, you let your mind wander to other landscapes that carry quiet danger in their stillness. Not because you need more fear, because the earth has a consistent personality and it expresses it in many forms. A volcano that looks like a perfect cone, for example. There are volcanoes shaped so symmetrically they seem designed, like they were molded rather than built. Snow on top, dark slopes below, a clean silhouette against a bright sky. They look calm because they are simple shapes, but a cone is a pile. It is a stack of lava flows and ash layers and loose fragments built by eruptions that sometimes alternate between gentle and explosive, and a pile always has a relationship with gravity. If the pile is steep and weak, it can fail. Some volcanoes have crater lakes, water filling the bowl left behind by an old eruption. Crater lakes are beautiful in the way still water is beautiful. They reflect clouds. They sit quietly, cold and deep, with steep walls around them that make them feel like secrets. But a crater lake is stored water at elevation. If the rim fails, if a landslide plunges in and displaces water, or if an eruption heats and disturbs it, the lake can become a sudden flood. In human terms, it is a bathtub on a mountaintop with a cracked rim. Then there are lakes that store a different kind of danger, gas. In a few places on Earth, volcanic CO2 seeps into deep lake waters and stays trapped under pressure. The lake becomes carbonated quietly. Most days, nothing happens. The gas stays dissolved, held down by the weight of the water above. But if the lake overturns suddenly, the gas can come out of solution fast, like opening a shaken bottle. A cloud of invisible heavy CO2 can spill down valleys, displacing oxygen. There is no drama in the air itself, no smell, no color, just an area where breathing stops working. Lake Nyos in Cameroon is the famous example, where in the 1980s, a sudden release killed many people in nearby villages. The lake looked calm. The danger was stored, not visible. Congratulations! You found a landscape where the threat is literally the air. And then there is ice above towns. In some mountain regions, glaciers hang over valleys where people live, and warming temperatures can destabilize ice and rock. Glacial lakes can form behind loose moraine dams, piles of debris left by retreating glaciers. Those dams can fail, releasing sudden floods called glacial lake outburst floods. Again, the pattern repeats. Stored water at elevation, a barrier that looks solid until it is not. Gravity waiting patiently. Humans respond the way humans always do. We monitor, we measure, we set up early warning systems, we build evacuation routes, we argue about budgets, we put sensors in places that do not care about sensors. And sometimes that works. Sometimes the difference between tragedy and a story you tell later is a few minutes of warning and a practiced route to higher ground. Sometimes the difference is simply luck, but the calming part, if you let it be calming, is that these landscapes are not chaotic. They are consistent. They obey rules, even if the rules play out on timescales that feel unfair. Water flows downhill. Rock breaks under stress. Ice creeps. Gas rises. Plates move. The danger is usually just stored energy being released. Heat, water, pressure, gravity. So when you return in your mind to Rainier, you do not return to fear. You return to a familiar system. A high volcano, iced and layered, feeding rivers with meltwater and sediment. A mountain that looks like a single object, but behaves like a whole network. It fades in and out of cloud, like it prefers privacy. And down below, the valleys remain open, green, and convenient, still shaped like old scars, still inviting people to live in them, still ready to guide whatever comes next. You can hear the river again, somewhere out there in the dark, moving steadily toward the sea, carrying tiny pieces of the mountain as proof that nothing here is truly still. And for now, the sound stays steady, the kind of steady that lets you forget, briefly, that steadiness is just one phase in a longer cycle. Steadiness is also what lets people practice not thinking about the sirens. You can drive through towns like Ording and see the neat geometry of ordinary life laid out on old debris. You see a baseball field flat as a sheet. You see houses with trimmed hedges. You see a main street that looks like it was designed to be uneventful. And you think, surely this place was chosen because it feels calm. But the calm is partly an accident of deposition. The lahar spreads out, loses speed, and drops its load. It makes a wide, flat surface, then walks away for centuries. Humans arrive later, point at the flatness, and interpret it as an invitation. You have that habit too, if you are honest. You see a smooth surface and assume it is stable. You see a gentle slope and assume it is safe. You see a green valley and assume it is friendly. And those assumptions work well enough, right up until they do not. So the region tries something very human. It tries to translate geology into routine. You get hazard maps printed in calm colors. You get evacuation route signs pointing uphill, away from rivers. You get school drills where children practice walking, not running, to higher ground. You get siren tests on certain days because a warning system is only useful if it is not forgotten. The odd tenderness is that this is not panic. It is administration. It is the same species that builds sidewalks, also building a plan for mud. And the plan is simple. Because the physics is simple. A lahar is heavy, and it prefers low ground. It will take the river valley, because the river valley is already the path of least resistance. If you are in that valley, the solution is not heroism. The solution is leaving the valley, up, sideways, onto higher terraces, onto any ground the flow would have to climb to reach. That is the whole strategy. Not fighting, not outrunning in a straight line, just stepping out of the channel that history already outlined. You can picture the landscape as a set of bowls and gutters. The gutters are the danger corridors. The bowls are where things pool. The high edges between them are, awkwardly, the safest places to stand when gravity loses patience. And this is why Rainier is called dangerous so often. Not because it is erupting right now. Not because it is uniquely evil, but because it sits above a lot of people, and the best paths for its most common hazard already point toward those people. It is a city planning problem designed by a volcano. Still, the mountain spends most of its life being quiet. It spends most nights hidden and most days merely scenic. And because it is quiet so often, it becomes easy to treat its danger like a rumor. A rumor with excellent branding. You hear the word volcano and you think of lava. Bright, obvious, cinematic. You think of ash columns and red rock and the kind of disaster you can see coming from far away. Rainier does not always offer that courtesy. Sometimes the most consequential events begin as internal weakening. Water circulating through rock, heat altering minerals, glaciers cutting into slopes and making them steeper, small earthquakes loosening a cliff. the mountain quietly turning parts of itself into something softer. Hydrothermal alteration is the tidy term. In human language, it is the volcano slowly marinating its own bones. Hot, slightly acidic fluids move through cracks. They replace strong minerals with clays. The rock becomes weaker, more slippery when wet, less able to hold steep angles. You still see a beautiful white cone from the highway, but inside, some zones are less mountain and more composted stone. This is one reason large landslides can happen without a dramatic eruption. The structure can fail because it has been quietly compromised for a long time. And when a large piece fails on a glacier-covered volcano, the result is rarely neat. It is a collapsing slope mixed with ice and snow and water, turning into that same dense, moving mess. The land does not need to be angry. It only needs to be heavy. You stand with that thought for a moment, not to scare yourself, but to understand the shape of things. It is always easier to relax when you know what the shadows are made of. Then you let the mountain drift upward again, back into cloud, because it prefers to be a silhouette. And you return to the surface details that make this place feel livable. Because even under a dangerous volcano, the day-to-day world is mostly made of small systems: streams, soil, trees, wind, the kind of gentle mechanics that never make headlines. And as you keep walking in your mind, you feel the forest return around you, not as a wall, but as a thick, damp presence that absorbs sound. Here, everything is designed to catch water. Needles catch droplets and hold them until they fall. Moss catches what the needles release. Rotten logs catch what the moss cannot hold. The soil takes what everything else hands down and stores it like savings. The water does not vanish. It just changes forms and containers. In a rainy climate, that water is the main sculptor. It does not carve with drama most days. It carves with repetition. A raindrop hits rock, and nothing seems to happen. Another hits, and another. Tiny acids in the water dissolve tiny minerals. In cracks, water freezes and expands, prying the rock apart with the slow persistence of a bad habit. Roots join in, thickening over years, wedging themselves deeper, because a tree is just another form of pressure. Then gravity takes whatever has been loosened and nudges it downhill in small motions that look like nothing. A pebble rolls, a patch of soil creeps, a bank slumps near a stream. The mountain is always being moved, even when it looks still. The forest makes this movement feel quieter than it is, because the forest is excellent at hiding raw change. It covers scars. It grows into gaps. It turns yesterday's landslide into next decade's green slope. But there are places where the forest cannot hide what is happening. Along riverbanks, for example, where water keeps undercutting the same edge, no matter how many roots try to hold it, you can stand on a riverbank and watch the land fall away in slow motion. The water does not need to be high. It just needs to keep touching the same spot. It steals grains from the bank, one by one. The bank grows steeper. Roots hang out into the air like exposed wires. Then, one day, the whole section gives up and drops into the water with a soft collapse. It is not dramatic, but it is final. The river carries the evidence away quickly, as if cleaning up after itself. This is the quiet version of the same system that makes lahars. dangerous. Undercutting, saturation, collapse, transport, deposition, repeat. And if you keep climbing again, if you let the forest thin and the wind strengthen, you reach the places where plants cannot do as much damage control. Above the trees, the ground is less stitched together. It is more like a loose pile, constantly adjusting. Here you can see volcanic deposits as textures, not as abstract layers. Pumice feels almost like a dry sponge in your hand. It is rock full of bubbles, frozen foam from gas-rich eruptions. Scoria is darker and heavier, still bubbly, like something that tried to be airy and failed. Ash is fine and gray, and it gets into every seam of your clothing like it is trying to become part of you. And the wind loves ash because ash is light enough to borrow. So it moves, it drifts into hollows. It gathers behind rocks. It forms thin sheets on snow. It migrates in small storms, then rests again. You start to realize that a volcano is not only defined by its eruptions, it is also defined by how easily its materials are moved afterward. A granite mountain sheds blocks, yes, but many of its pieces are heavy and angular. A stratovolcano like Rainier sheds a lot of fragmental material, things that were blasted or flowed or fell, already broken. Things that are easy to pick up and carry. That makes the mountain efficient at feeding rivers with sediment. It also makes its slopes more prone to certain kinds of failure. So, you do not need to imagine a single apocalyptic day. You can imagine 1,000 small days, each one moving a teaspoon of the mountain downhill. And then, you can imagine the rare day that moves 1,000,000 tons, because the small days prepared the slope for it. The Earth is like that. It prefers to do most of its work in silence, then occasionally remind you that silence was never the same thing as stillness. Now you let that thought drift away, because it is heavy in the way wet soil is heavy, and you move back to a different kind of patient violence. Water, given enough time, makes canyons. You already stood at a rim and listened to the river gnawing at its own channel. Now, in your mind, you become one of the grains that river carries. Not an important grain, not a special one. Just a small piece of volcanic rock broken loose on a slope, knocked into a stream, and now surrendered to transport. At first, you bump along the riverbed because you are heavy enough to stay down low. The water pushes you in short bursts. You roll, then rest. Roll, then rest. Each roll chips your edges. Each collision rounds you a little more, like the river is sanding down your personality. In high water, you travel farther. In low water, you wait, wedged between other stones, listening to the current hiss above you. You learn quickly that rivers are not steady creatures. They have moods. They rise and fall. They change temperature. They change clarity. They change their grip. In spring, meltwater makes them colder and fuller. In heavy rain, they turn brown and louder, loaded with soil and broken branches. In late summer, they can run clearer, lower, more exposed, showing you gravel bars that were underwater a month ago. Each season rearranges the bed. Each flood resets the furniture. And the canyon that seems permanent is really just the negative space of that rearrangement. It is what is left behind as the river keeps taking. There is something calming about that honesty. The river does not pretend to be eternal. It is always in motion. It is always working. It has no narrative other than downhill. Eventually, you reach lower gradients. The water loses some speed. You are dropped on a bar, then picked up again, dropped again, picked up again. The river becomes a conveyor belt with frequent stops. And then, eventually, you reach the place where fresh water meets salt. The river mouth is not a clean line. It is a zone of mixing. Fresh water pushing out, salt water pushing in with the tides, sediment settling where the current slows, sandbars building and shifting like living things. This is where your grain of mountain might finally rest for a while. You might become part of a beach, a dune, a spit of land that grows and shrinks with storms. You might be blown inland by wind, caught in beach grass, and held there until the next big storm tears you out again. The coast is not a finish line. It is a handoff. Waves take what rivers deliver, and then they start moving it sideways, up and down the shoreline, stealing from one place and feeding another. Longshore drift is a gentle name for a constant theft. Waves arrive at an angle, push sand up the beach, then gravity pulls it back down. The net motion is along the coast, grain by grain. In time, entire beaches migrate, river mouths shift, sand spits grow like fingers pointing into the sea. Storms accelerate everything. In storm season, waves carry more energy. They bite into dunes. They flatten berms. They carve steep scarps into sand that looked stable yesterday. Then, in calmer months, smaller waves return some sand, smoothing the slope again. It is like watching the planet make and unmake the same sculpture over and over, never quite satisfied. And offshore, the seafloor is also moving, even if you cannot see it. The subduction zone sits out there, locked and quiet, like a giant hinge that will eventually slip. The coastal landscape carries reminders, not only the tsunami signs and evacuation routes, but the geology itself. In some places, you can find layers of sand inland, thin sheets deposited by past tsunamis, then covered by soil again. The sand does not belong there, in a marsh or forest. It is a pale fingerprint left by an ocean that briefly walked onto land. People dig cores and find those layers. They date bits of plant material above and below. They build a timeline of past waves because memory is useful when you live near a patient threat. And if you step back from the ocean and face inland again, you see how the whole region is a conversation between uplift and erosion. The mountains rise because tectonics pushes and magma accumulates. The rivers cut because gravity insists. The coast rearranges because waves never stop. The forests grow because water is plentiful. And then forests rot because that is what forests do. None of it is finished. None of it is designed for you, and still you live in it. Because humans are very good at living inside unfinished stories. Now, since the earth loves to repeat itself with variations, you let your mind wander through a few other places that carry that same quiet danger. Not because you need more threats, but because it helps to see the pattern. You start with a perfect cone volcano, the kind that looks like a geometry lesson. In the tropics, you might see one rising above jungle, its slopes dark with ash soil and plants that thrive on minerals. In colder regions, you might see one wearing snow, its crater hidden, its symmetry almost polite. You think symmetry means stability. Wrong. Symmetry often means youth. A perfect cone is often a volcano that has not yet been deeply carved by erosion. It has not yet had time to collapse into complex ridges and valleys. It is still, in a sense, a neat pile. And neat piles are sometimes precarious piles. Some cones erupt frequently with lava that flows easily, building gentle slopes. Others are made of ash and cinders, steeper, looser, more likely to slide when saturated. Some hide thicker magma that plugs vents, trapping gas, making eruptions more explosive when they finally happen. The mountain looks calm, but it is storing potential in chemistry and pressure. Then you shift to a crater lake because still water has a way of making humans trust it. A crater lake is a wound filled with water. It sits in a bowl that used to be a vent. It can be astonishingly clear because there is not always much sediment coming in. The surrounding walls are steep and dark, and the water can look like ink, especially under cloud. But crater lakes are often perched high. That means their water is stored energy, held back by rims that were built by eruptions and collapses. If that rim is solid bedrock, the lake can be stable for a long time. If the rim includes loose volcanic debris, a landslide can cut it, and the lake can drain catastrophically. Even without a rim failure, an eruption beneath a lake can flash water into steam. Steam expands violently. It can drive explosive activity called a phreatic eruption, which is a technical way of saying water got involved, and everything became more sudden. People love lakes because they look like rest, but a lake in a crater is sometimes more like a savings account of trouble, waiting for the wrong withdrawal. Then you visit the kind of lake that stores not water energy, but gas. You already heard of Lake Nyos in Cameroon, where CO2 built up in deep water, then released in a sudden overturn. The physics is simple, and that is what makes it unsettling. Cold, deep water holds dissolved gas under pressure. As long as the lake stays layered with denser water below and lighter water above, the gas can remain trapped. But if something disrupts that layering, a landslide, a cold rain, a small volcanic pulse, the deep water can rise. As it rises, pressure decreases. Gas comes out of solution. Bubbles make the water less dense, so it rises faster. More pressure drops, more gas escapes. It becomes a runaway uncorking. The released CO2 is heavier than air, so it spills downhill like an invisible fog, filling low places. It displaces oxygen. People and animals in valleys can simply stop being able to breathe without knowing why. No fire, no lava, no sound that matches the danger. After that disaster, engineers installed degassing pipes to vent CO2 slowly, like letting a carbonated drink go flat on purpose. It is one of those very human solutions that feels both clever and slightly absurd. You cannot change the geology, so you install a straw, and then you move to ice again, because ice is always a quiet threat when it is perched above you. In the Himalayas, in the Andes, in Alaska, in the Alps, you find glacial lakes forming as glaciers retreat. They often sit behind moraines, ridges of loose rock and debris shoved into place by ice. Moraines can look like solid dams, but they are not concrete. They are piles. If water overtops them, or if a chunk of ice falls into the lake and makes a surge, the dam can erode quickly. the lake can empty in hours, sending a flood down valley that carries boulders and trees, stripping banks and wrecking bridges far below. It is called a glacial lake outburst flood, which is a long phrase for a short event. Again, the pattern is familiar. Stored water, unreliable barrier, gravity weighting. People respond with monitoring and engineering. They lower lake levels with channels. They reinforce moraines. They build early warning systems with sensors that detect sudden rises. The work is never done because the landscape is not done. And now you return to the Cascades one more time because it is easier to hold the concept when it is closer to home. In the Cascade Range, besides Rainier, there are other volcanoes with their own quiet hazards. Mount Hood, for example, sits over river valleys in towns in Oregon. It has glaciers too, and it has produced lahars in the past. Mount Baker has a history of hydrothermal activity, and it has shown increased steaming at times, reminding everyone that heat is still present. Mount St. Helens, of course, has already performed the dramatic demonstration in 1980, removing its own side in a lateral blast. It is a reminder that volcanoes are not obligated to be symmetrical, and that an eruption can be less like a fountain and more like a structural failure. But even St. Helens, after the headlines, returned to long, quiet years, building a new dome, reshaping its crater in small increments. The Earth is very good at returning to routine after violence. That routine is what you are following tonight. Not the drama, but the process. And the process always comes back to energy being stored and released. Heat stored beneath a volcano, water stored as snow and ice, stress stored along a plate boundary, gas stored in magma or deep lake water, sediment stored on a slope until it finally slides. The planet is a ledger of stored things. Humans are also a ledger of stored things, worries, and plans and unfinished thoughts. Maybe that is why landscapes like this feel strangely relatable when you stare at them long enough. Because the Earth is not calm. It is just slow. Now, you let the catalog of other hazards fade, and you bring your attention back to the single familiar silhouette of Rainier. Not because it is the only dangerous place, but because it is a perfect example of how danger can be ordinary. You picture the mountain as it usually appears, wrapped in cloud, quiet enough to ignore. From a distance, it looks like it is sleeping. From closer in, you remember the creak of ice, the murmur of rivers, the crumbly volcanic layers under thin soil. You remember that some of its rock is chemically softened, altered, ready to fail when shaken or soaked. You remember, too, that the lowlands are not separate. They are connected by valleys that behave like aim. That is the part that makes Rainier feel intimate. It is not a remote peak you visit and leave. It is a machine that feeds the region, with water and sediment, with fertile soils and scenic backdrops. And, like many machines, it has failure modes. So you imagine the warning systems again, not with alarm, but with a kind of respect for the attempt. There are lahar detection systems in some drainages, using sensors that can notice the ground vibration of a moving flow and changes in river stage and the signature of sudden sediment-loaded water. They send signals to emergency management. They trigger sirens. It is a strange thing when you think about it. Humans have built ears for rivers, not because we can stop the flow, but because we want to be less surprised by it. The plans in lahar zones often assume you do not have time to drive. Roads clog, bridges can be compromised, so the plans often emphasize walking routes to high ground, practiced in daylight, remembered at night. It is a humble strategy. It admits that when physics arrives, you become a pedestrian again. And then there is the other quiet reality. Even with maps and sensors, the exact onset is uncertain. Some lahars could start from sudden slope failures that are not preceded by clear signals. Some could be triggered by earthquakes that are themselves sudden. The systems are not perfect. They are simply better than having none. That is the human condition in hazard landscapes. You make imperfect preparations for events that do not care about your preparations, and most nights, those preparations remain unused. Most nights, Rainier just sits there, accumulating snow, shedding meltwater, feeding rivers with silt. Most nights, the hazard is only a possibility, tucked into the shape of valleys and the memory of deposits beneath towns. If you stand at night in the forest, you can sometimes hear the river more clearly than in the day. Traffic is less. Wind settles. The sound of moving water becomes a steady, low presence, like an engine idling somewhere far away. That sound is not only water. It is transport. It is erosion. It is the mountain being converted into smaller pieces. You can picture a single grain again, being carried, dropped, carried again. You can picture it taking years to move a mile, then moving 10 miles in a single flood. Time is uneven like that, and the mountain, of course, is not only being worn down, it is also still being built in the deeper sense, not rapidly, not like a construction crew, but by the slow supply of magma from below rising into storage zones, cooling and crystallizing, pressurizing and relaxing. You can think of the volcano as a long-lived compromise between supply and loss. Eruptions and intrusions add material. Landslides and erosion remove it. Glaciers carve it, rivers export it. The shape you see is just the current balance point. Over thousands of years, that balance shifts. And, speaking of shifts, you can widen your view again to the tectonic setting, because it is always the unseen metronome. The Juan de Fuca plate continues to sink, carrying water down, feeding melt above. The Cascadia subduction zone continues to lock and strain. The coast continues to rise and fall in slow pulses of interseismic uplift and sudden drops during earthquakes. Even without the big earthquake, the region experiences smaller quakes, deep ones within the subducting plate. Shallow ones in crustal faults? Most are too small to do much. Some are felt as a brief shiver, a reminder that the ground is not a promise. And Rainier listens to those shivers because a volcano is a structure full of cracks and slopes and ice. It is sensitive to shaking in a way flat land is not. That sensitivity does not mean disaster every time. It means the system is primed, and sometimes small triggers matter. If you want to keep this gentle, you keep it simple. A high mountain is stored energy. It stores water as snow and ice. It stores rock as steep slopes. It stores potential as elevation. And it sits in a region that stores tectonic stress. That is not a curse. It is just the setting. And because it is the setting, it shapes how people live. Building codes in the Pacific Northwest account for shaking. Bridges are engineered with earthquakes in mind. Some schools practice evacuation routes. Coastal towns post tsunami signs. Communities in lahar zones install sirens. Meanwhile, people still go to work. They still walk dogs. They still complain about rain, as if the rain is not the entire reason the region looks like this. That is the part that feels almost comedic in a quiet way. Congratulations, you live on the edge of a subduction zone, under a glacier-covered volcano in a rainforest climate, and you are annoyed by drizzle. It is the most human response possible. Now, you let the sardonic thought drift away, and you move back into the physical world of Rainier's slopes, because there is one more comforting detail worth lingering on. Even the dangerous processes here leave beauty behind. Lahar deposits, over time, become fertile soils. They build floodplains that grow thick forests. River terraces become places where people hike and farm. Glacial silt makes rivers look like liquid stone, pale and luminous under gray skies. The same volcanic ash that can be a hazard in an eruption also supplies minerals that plants use. That is why volcanic soils can be so productive. The land breaks itself down and life takes advantage. It is not kindness, it is opportunism. And it means the landscape is always recycling. The mountain sheds material, the rivers move it, the lowlands receive it, plants grow in it. Those plants die and become soil. The soil washes again. It is a loop, and you are living inside it whether you think about it or not. So you return once more to that quiet forest trail at Rainier's base. But now it is later. The light has changed. The clouds are lower again, or maybe higher, shifting like slow thoughts. You can feel the dampness in everything. Bark is dark with water. Needles stick together. The ground gives slightly underfoot. If you listen carefully, you can distinguish different waters. There is the thin drip of canopy runoff, slow and irregular. There is the small hiss of a nearby seep, water emerging from soil and vanishing again. There is the deeper continuous sound of a river farther away, steady enough to be background. And above all of it, you imagine the ice, not visible from here, but present. Glaciers tucked into valleys near the summit. Ice cliffs where the mountain is steep. Snowfields that will compress into new ice, then begin their slow downhill creep. It is strange to think of ice as motion, but that is what it is. A glacier is a conveyor belt of frozen time. Snow falls, is buried, compresses, becomes ice. The ice flows, cracks, reforms. It carries rocks embedded in it, grinding the bed beneath. It delivers meltwater at its snout, and that meltwater becomes rivers. And when the climate warms, the balance shifts. The glacier thins, the snout retreats uphill. Meltwater patterns change. Sediment delivery changes. Slope stability can change as ice that once buttressed a wall is removed. Again, no single dramatic guarantee, just altered conditions. So the future valleys will not behave exactly like the past valleys, even if the basic physics stays the same. Gravity stays, water stays, the details adjust. And humans adjust too. Slowly, through engineering and planning and forgetting and remembering. You can feel how the region carries both memory and amnesia. Memory in hazard maps, in siren tests, in scientific papers that quietly count past deposits. Amnesia in the ease of daily life, in the way a shopping center can sit on lahar sediment without anyone thinking about the word lahar. Both are normal. Both are part of living on a restless planet. And now, since you have wandered from volcano to canyon to coast and back again, you let the story settle into something simple and grounded. Rainier is not a monster. It is not a guarantee. It is a tall structure built by deep earth processes and carved by weather. It is dangerous in the same way a steep roof is dangerous in winter. Most days it does nothing. Then the wrong conditions arrive, and gravity does what it always wanted to do. It is dangerous because it is useful too. Its ice supplies water in dry months. Its sediment builds soil. Its presence shapes the entire region's climate and rivers. It creates beauty that pulls people close to hike and photograph and build cabins with views. You want to be near it because it feels like meaning in a skyline, and the mountain, indifferent as ever, allows this closeness most of the time. So you stand in that indifference for a while. You listen to the water. You imagine the valleys as old channels waiting to be reused. You imagine the subduction zone offshore, storing strain with quiet patience. And you keep the tone gentle because the Earth's violence is not always loud. Sometimes it is just a long, slow pressure problem waiting under moss. Sometimes it is just warm rain falling on snow, turning a mountain's storage into a sudden release. Sometimes it is just a river, never tired, carrying away the evidence. You let those thoughts drift like cloud around the summit, and you remain here in the mountain's shadow, where everything is still moving, but slowly enough that the forest can pretend it is permanent, where the rivers keep exporting the mountain, grain by grain, where the lowlands keep receiving what comes down and building ordinary life on extraordinary history. And as you follow the sound of water again through the dark trees, you begin to notice how the night air cools with elevation, and how the cloud ceiling lowers, and how